In this next unit, we're going to be talking about whether points are a solution to an equation and in a graph. Now, a point looks like this. There's an x value and a y value, and we want to know what makes a particular point, an x and a y value, a solution. In an equation, what makes the point a solution is that the x and y values make the equation true. The x and the y values make the equation true. What does that mean? Let's take a look at a couple examples. Remember that a point is always an x value and a y value. So if I take this x value and this y value, and I plug them in, does it make the equation true? So let's see, I'm going to plug in, right? This is my y value. I'm going to plug in, and here's my y. So I'm going to plug in 4 equals, I'm bringing down 5. This is 5 times x, right? We know this is multiplication when a number is next to a variable. So this is 5 times 3. That's my x value. Minus 7. Now let's see, is this equation true? So I'm going to just bring down 4. The only math I'm doing here is 5 times 3, which is 15. And then I'm going to do 15 minus 7, and I get 4 equals 15 minus 7 is 8. So is that true? No, this is not true. 4 does not equal 8, and so 3, 4 is not a solution to this equation, and I would write no. In this example, I'm doing the same process. Notice the equation looks a little bit different, but I'm still plugging in this value for x and this value for y. My points are always x comma y. So this is 2 times x, so that's 2 times 4, minus 6 times y. Okay, the y value is negative 2. Careful and make sure you catch that negative, equals 20. 2 times 4 is 8. This is negative 6 times negative 2. Negative times negative is positive, and 6 times 2 is 12. And then I get 8 plus 12 equals 20. So does 20 equal 20? Yes, it does. So this point is a solution to this equation. On a graph, it's actually really fast and easy because the point is a solution to this equation if it's on the line. The point is on the line. Okay, so for example, here, this point, negative 2, 3, if I go to negative 2, 3, I see the point is right here. Is it on the line? Yes, it is. So that is a solution. Notice that I could also plug this x and y value into this equation if I wanted. And this is a great example to watch really quick because if you're uncomfortable multiplying by fractions, this is a good way to get that review. Oh, and sorry, look, I wrote y here, but what should I have written for y? I should have plugged in this 3. Okay, so now we're going to see, does it make it true? Now we already know the answer is yes because we see the point on the line, but let's just do this math really quick. So I'm going to first do this multiplication. That's 1/2 times negative 2. That looks like this, 1/2 times, I can turn this negative 2 into a fraction by putting it over 1. Then I'll multiply across. 1 times negative 2 is negative 2. 2 times 1 is 2. And this becomes negative 2 divided by 2, which is negative 1. Okay, so this becomes negative 1. And negative 1 plus 4 is the same as 4 minus 1. That's 3. And we can see this is true. Okay, so we didn't need to do this, but we could see that the point was on the line right on the graph, and we double checked it here.